Hey everybody, Chris at McSteed TV here, and I wanted to cover some of the scripts and stuff that I did, things that I did to solve getting a motorcycle to work in Unity, a 2D motorcycle. I see a lot of questions like this on the internet, and I built a game a couple of years ago called Moto McSteed, which I love playing. It wasn't a huge hit or anything, but I played it every day, and when I went to go update the game, it just, in the new version of Unity, the physics engine just exploded. So I had to kind of recreate everything. But ultimately, I ended up way happier with what I had. And the original version was made using all pretty much off-the-shelf physics pieces within Unity, such as hinge joints and things like that, and the slider joints. And I got it to work pretty good, but I was always frustrated by some of the limitations, mainly with the spring component. And it just didn't have the amount of control that I wanted. In the real world, with off-road vehicles, you have springs, but then you also have shocks. And those shocks on higher-end stuff is adjustable for both compression, meaning when the shock is being pushed down, and in rebound, which is when the spring is trying to force the wheel back out. And the Unity version of the spring controller doesn't have anything like that. It has the one thing that you can set, which is just the damping, and it's maxed out at 1, and even at 1 it doesn't quite control things the way I wanted to control. So I ended up doing a lot of research and creating my own. So let me really quick, I'm just going to play the game for a couple seconds so you can see how it works. So you can see my Ghost Racer, which I got just implemented just now. But you can see going over those bumps and all that stuff, how the wheels absorb the hits and don't get too wild. So, and that's not even on the top setting of the game. The big thing that I did, one of the bits that I found on the internet, and I'll try and find a link to the tutorial that I followed to sort of get to understand a way to make the springs work the way I want. And it looks like I'm not going to be able to get... I'm going to stop the thing for a second. Okay. Let me hit play again. So now you can see on this bool right here, says compressing, and this is just the one for the front suspension. I made separate settings for both the rear and the front suspension. That way I could really fine-tune them. And this is one of the lower settings in the game, so the compression and rebound control are fairly low, but the springs are stiff, mimicking the way older motorcycles were. Because the suspension wasn't very tall, it had to be stiffer in order to resist being bottomed out. And so for the upgrade process, which I can cover in a different video, you get longer suspension and better compression and rebound control. So the script was really the heart of getting this game to work. The previous, or the default spring control in Unity just flat out did not work for me. And I looked for other solutions and finally came to the conclusion I just need to write my own. And I did find quite a few things explaining how spring math is done and all that stuff. And that helped, but mostly this other guy's tutorial helped get me off in the right direction. And then I was able to modify things to get it to be more what I wanted. So one of the other things that I wanted to do is the setup, getting a spring set up correctly in Unity. It's for some reason it's just like it's not very intuitive. The same thing with slider joints. By the way, I am using slider joints for the suspension. I tried actually building the suspension with a swing arm connected to the wheel and all that stuff the way a motorcycle is really, but it's an unnecessary complication. I had found back when I did the original game a script that would help point the swing arm at the wheel at runtime, and it's just a simpler solution, and it behaves enough like the real thing that it doesn't matter. But so one of the things I wanted to do is I didn't want to have to get like all the like connected anchors and all that stuff. Like they're kind of a nuisance to get aligned sometimes. So what I did, the best thing that I found for connecting, like calculating the math for these connections, is to use just transforms or rigid body connections. So let me go back to the script for it. So you can see right here, there's a connection for the game object for the rear hub. So I actually have the wheel itself is connected with a hinge joint to the hub. That way I could have separate control from the wheel and the suspension. And then it also has this mount point. So there's the rear mount and front mount. And those are, let me go to the rear mount is this, which is connected by a hinge joint to the body of the motorcycle. And all it's doing is going and getting the position of that, and the position of the hub, and it's comparing those for the thing I showed you earlier, where it's comparing whether it's rebounding or compressing. And the one of the by doing that, I don't have to do a ton of setup. Like I don't have to sit there and try and calculate things. I just place the object. I place this mount where I want it to be, and then I place the wheel where I want it to be, and the math will just work out because it's using those objects as its reference point. And then the hinge joint, I just roughly align the angle to what it would be on a real motorcycle. Like, as if I go to the front wheel, if I can get it to highlight, because as you can see, I have tons of hinge joints on this thing. Yeah, I lose track of which ones are. I mean the slider joints, not the hinge joints. So yeah, here you can see right here, this is the angle of the slider joint. And it doesn't actually matter that the spring is in that particular position, like aligned to this. But, you know, I guess it's just aesthetics. I could actually mount it below the ground. It really wouldn't matter as long as the spring works the way you want it to. So, and then I also have hinge joints that the rider is attached to and things like that. All right, so now I'm going to go through some of the things in the script. So I'm not a great coder, and almost everything in this entire game are the results of me taking things that I found on the internet and just slamming together in any way I can until it just works. The things that I wanted to accomplish is I didn't want to have to set the height or the length of the spring. That's why I used the mount that I showed you earlier, and all those kinds of things that help determine it. And then I ended up setting that length anyway as part of the upgrades, but I'll get into that later. So I just want to go through some of what the things are here in the script. So public game object rear wheel, that is the wheel itself. I used to have this script running on the wheel, not on the body, but I wanted to get all of my controls for the bike all into a single place, meaning on the body of the thing. So I have a game object. It's getting the rear wheel, and then the spring mount on top of that, and then also the slider joint that it's connected to. I don't remember if I used that. I'll have to look. I might have been using that to check the velocity at some point, but I'm not sure. I don't think it's in the script anymore. So the private float is a damper. Both of these are internal things that are steps in the math. And those kind of come from that other tutorial that I've been mentioning. And then these controls here are where these are my user controls, the controls that I adjust in the inspector until the bike works the way I want it to. So spring force, actually no, this could actually be a private, but it is something that's calculating how much force the spring is actually pushing at a given frame. The compression is simulating the compression amount in a shock. The rebound is simulating the rebound amount in a shock. And then the spring rate is equivalent of the rate of a real spring. And then the rest length is the length when the script first runs. It says how far is the wheel from that mount, how far is the hub from the spring mount. Then the override is a number that I use to add to or subtract from the rest length. So if I want the bike to ride lower or taller, I use this number to adjust that. And then these here are part of the internal math. And then this section here is just the same thing but on the front wheel. Okay, so upgrade override, I use player prefs to set the level of upgrade. And I have, just for testing purposes, a checkbox of upgrade override up here somewhere, right here, that I can just click, and then I can just set the number of the suspension, because I ride every track at every level of suspension and engine to make sure that it's fun for everyone. And that's actually one of the things that I really love about this game is the fact that you start out on a lower quality bike, but as you upgrade the bike, even these old tracks that you rode that were fairly simple become a completely different challenge because of the speed of the bike and all those kinds of things. So it completely changes the experience. All right, this stuff here is all just getting the those overrides, the upgrades. It's getting it from scriptable objects that I use to contain the different settings. Okay. So this math, I don't completely understand. I've seen it spelled out as an actual formula, and a lot of it I think could be done in a single line. But the tutorial I followed spread it out into individual lines, which actually made it easier for me to semi-understand it and modify it. So like I said earlier, previous length equals current length. That sets that. And then the current length, the very next line, is changing the current length to be the updated thing. That way it has a number to compare. And then it's a vector 2 comparing the distance between the rear wheel and that spring mount, and it does that every frame. And then it says if the previous length I have a little bit of a cold right now. If the previous length is less than the current length, then damp result. Remember I showed you the variable earlier that I said was part of the calculation. So if the previous length is less than the current length, then the damp result is equal to the compression. So that's one of the user settings that I do. It's saying that if the suspension, the distance in the suspension is getting smaller, then you're using the number from the compression side. And it sets compressing to true. Else if the previous length is greater than the current length, it says, okay, well, it's getting farther away, meaning the wheel is going back out towards its rest position. Then it changes the damp result to be the rebound number. So the reason I did it this way is I use damp result down here in the actual math rather than the compression or rebound number. That way this thing tells it these if statements tell it that the damp result that you're actually using for your calculation is based on this number or this number. So then the spring velocity is saying, okay, the current length minus the previous length divided by time, that fixed delta time. So that is just saying how much did I move in one frame to the next. And then the spring force is equal to the spring rate times the current length. And what that does is the force is equal to, or the force is different based on the length of the shock. And that current length is based off the resting length, not the actual length of the thing. So what that does is as the wheel position gets farther away from the resting length, the spring will actually push harder to get it back to its resting length. And then damper underscore R, that's R is for rear, is equal to the damp result, meaning this number up here that's saying whether you're compressing or rebounding, times the spring velocity. Now again, I sort of understand this, but I don't completely. But this statement takes the spring velocity and tries to control it based on the dampening number. That's the gist of it. And then it takes that number. So spring mount, we're getting the rigid body and we're adding a force based on the direction. See up here we have the vector direction, which is the direction from the spring mount to the wheel. And it's checking that every frame, so it always knows which direction it's going. And then we're adding the force, the multiplied by the spring force plus the damper result. So what that's doing is if the wheel is getting pushed towards the body, that spring is also pushing the body up. And in reverse, the wheel is also being pushed by the body of the bike. And then all of this, again, is just what is being, it's the same thing, but for the front wheel. I'm sure someone could do this all in one routine, but every time I try to get my code to be the way other people do it, where they're using separate functions to call within the update and all that kind of stuff. Almost every time I do that kind of work, it ends up just confusing me. So a lot of times I have stuff like this where it's just like every version of it is all just in a line in the script. And it works, so why bother? I should cover this. I think it's a little bit off topic for this video. I don't know if anyone knows, or anyone watching this knows what a scriptable object is, but I watched one of the tutorials on the Unity site on using scriptable objects to make gun upgrades. And so I did a lot of research on that. I watched that video several times and managed to make scriptable objects that contain... I'll just pull up one of the scripts and then you can see. Let me see if it'll come up in... So these are the scriptable objects. I won't even attempt to explain what a scriptable object actually is. But basically it's just a bit of code with variables in it. And then the bike itself doesn't actually contain these scriptable objects. My game manager does. Let me go to that really quick. So my game manager has, since we're talking about suspension, I'll open this up. It has these 10 scriptable objects in an array. I cheat. I hate dealing with the 0 in arrays, so 0 for me on most arrays that I create is just a dead thing that I never call, because there's so many other scripts that I always end up having to subtract one and all that stuff. It just, to me, it makes it messy. Messy to think about. I mean, it might be more elegant code-wise or anything like that, but I'm not writing poetry. So I always just leave 0 to be a dummy thing. But let me go back to the suspension. So I have different ones for shocks and different ones for springs because they're different upgrades in the game. So what the scriptable object contains is the price of the shock, which for some reason is not showing up here. Oh, because level 1, that's what you start out with. There's no reason to have it a price. Level 2 is $200. I didn't bother putting a description. That was something that was in the tutorial, and I kind of just didn't need it. The compression rate, the rebound rate for the rear shocks, and the same for the front. And as you go all the way up, you can see these numbers, they increase every time. And that's how you get upgrades. You buy them in the game. Here, I can show you in the thing really quick. Maybe. Oh, my menus are set up to work on iOS, so they're not showing up. Well, the upgrades, so it gets all the upgrade and the price, and also the suspension gets the settings from those scriptable objects here. So compression for the rear is equal to shock's object, which is the thing I just showed you. And then current shock is the number that sets the number from the upgrade amount, of the upgrade level. It sets which scriptable object it's actually pulling it from, and then this is the variable it's calling. And it's the same thing all the way down the line for shocks, spring rate, and all that stuff. Like I said, I can do a separate video if people are interested on all of that setup. So now that I've kind of covered the basics of the suspension, I will cover what is actually driving the bike. So one of the big things for me that was really important is that this actually works kind of like a real motorcycle. And I I downloaded, I don't know, like 50 something motocross games for, I'm doing a terrible job of writing right now, for iOS. I tried every one I could find, you know, starting from the ones that are really popular, like Mad Skills and all that stuff. And every one of them seems to say mind-blowing physics. And I played all these games, and the physics were, they felt like platformer game cheats rather than real physics. And I wanted the game to be physics driven. And I also wanted the game to be fast and rough. Because you watch motocross games and the bikes are getting, or not motocross games, but actual motocross, and the bikes are getting kicked all over the place. The wheels are dancing around. And actually, I'm going to load one of the old Moto McSteed levels. And not all of them work anymore, but see if I can pull one up, and then you can see what I mean by them being rough. You notice that the suspension is, when I'm on the level spots, the suspension is always working. But if you look at a game like Mad Skills, it's just kind of, it feels, I don't know how they actually did it, and their programmers are way better than me. But I knew what I wanted out of a game, and that game didn't provide it. But they have sales. I don't. So you see how the ground is rough, and that is what I wanted out of the game. And I wanted it to all be physics driven. So like I could have cheated and made the velocity of the bike just by doing an add force and having it just drive straight from behind the bike, but I wanted the power to be driven by the wheel. So let me go back here, and I will select the wheel object. Actually, no, as I said earlier, I moved this all to the body of the bike, so I didn't have to go hunting for the connections to these scripts. So I have this script called wheel power, which, like everything else, I started out just finding other people doing something similar to what I wanted to do, and then adapted it until it worked the way I wanted to. So as you see, I got engines. These are those scriptable objects controlling the engine upgrades. And then I also have the upgrade overrides here. I have a horsepower setting, a torque setting, and then a transmission setting. Now, these aren't really horsepower and torque. It's purely all done with the add torque. But in using a lerp, I'm able to have what I'm calling torque is just how fast the engine is getting up to its speed. So this is one of my more complex scripts, although there's not a ton to it, but it's one that I've had to go back into so many times because something I have working suddenly doesn't work anymore. So as I showed you earlier, I have the float horsepower, which this number 14,000 was purely an old number. I might as well get rid of it, but I'm worried it'll break something. The big upgrade that I made from Moto McSteed to Robo Moto is this ability to control not only how fast the bike gets up to power, but how much top speed it has, which I had done tutorials on that in when doing Moto McSteed, but they never worked because I didn't really understand it. And I may have even tried the exact same solutions, but it didn't work the way I thought it was going to, so I just kind of quit and went with something that made sense to my brain at the time. This is a philosophy of mine, and I worked with this guy, Dave, who had a software engineering degree, but Dave and I used to get into arguments all the time because he always wanted things to work the way he thought they should work. And I would always say, well, do it the way it actually works, not the way you want it to work. And so sometimes that results in giving up. But, there's this old stupid test for like determining someone's life philosophy is if you're presented with a wall, do you go over it, do you go around it, or do you go through it? And it's supposed to represent going around it is like avoiding your problems, and going through it is whatever. It's stupid. But this time I decided I'm going to solve all the stuff that doesn't work. So the wheel speed was one of those big changes that I did, and that the wheel speed is capping how fast the wheel turns. It's that simple. And when you're playing the game with the upgrades, you can see if I have a lot of horsepower, you'll see the Ghost Rider will, I will pass him off the line, but then we run neck and neck because the wheel speed is the same. And conversely, I could have less horsepower but higher wheel speed by upgrading the tranny rather than the engine, and then I can beat him in top end. But if I start getting into bumpy stuff that requires more power, I start to lose thing. So engine braking, I actually ended up turning this off for the most part, but the idea of it still appeals to me. What it is in a real internal combustion engine, if the wheel is turning and the bike is in gear, the compression of the engine is slowing down the rear wheel. And that was something I played with happening. So when you let off the gas, the bike was actually slowing down. But it was causing other problems with the physics, and I never quite figured it out. So brake dive, when you hit the brakes on any kind of car that has suspension, the front suspension compresses as you're on the brakes. And this is one of the cheats that I do. I'm adding torque to the chassis of the bike, the body of the bike, to simulate the brake dive more. But it also helps me achieve something that real motorcycles do. If you are in the air and you hit the rear brakes on a motorcycle, it causes the front end of the bike to pitch down. It's because all that momentum in the wheel is being then transferred through the swing arm and into the body of the motorcycle. And also on the other side of that is if you're on the gas when you're in the air, it causes the front end to go up for the same reason. Squat is the opposite of brake dive. When you get on the gas hard, it causes the back end to drop because you're having this rotation force tweaking or pushing, rotating the bike along. In the game, it's along the Z-axis down back towards the rear wheel. And I don't remember if I actually used that, but if it is being used, it's adding a rotational force to the body because Unity isn't the real world, so some of those forces weren't transferring the way that I wanted them to. So this is covering the upgrades to the brakes. And so rear brake power and front power, I have numbers that are controlling how well the brakes work, partially for the upgrades, but also just trying to tweak the way the brakes work so they don't instantly lock up, and they also just don't work. Because in Moto McSteed, I actually never got the brakes to be able to hold the bike still if you were on a hill, and I fixed that in this version. So this lockup, I'll show you down a little bit later, is the rotational velocity that if the wheel gets below, it lets the wheel lock up completely. Because I'm actually using the freeze rotation on the rigid body to get that lockup. So again, this is the scriptable objects controlling there. This here is just checking whether the wheel is on the ground. That's mainly for the dust coming off the rear wheel. It only makes it if it's on the ground. So I have a couple of setups. I have the gas fired that's driven by the joystick, but I'm actually going to skip that and go to the one that's powered just by buttons. I have all these different possibilities for what is making the gas do what it does. Then I have this function. This is a case of me doing what I said I don't generally do, but I was tired of rewriting this code in 15 different places. So let me jump down to that function. So I got a public void of throttle, and you pass into that a float, which you see with the button powered one. Where did it go? The button powered one, I'm passing in 1 because I want the button is just going full on right now. In the joystick powered one, it's getting input from the axis, the horizontal axis. So going back down to throttle. I don't know why I put this check in, but I had some reason at some point. Oh. Well, this is where, as I said earlier, I'm adding torque to the body of the motorcycle as I'm on the gas. So this is called, it makes sure there's a chassis for no reason. I could comment that out right now and it wouldn't affect the script at all. And then it's also setting the angular drag of the wheel. And this is part of the engine braking that I talked about earlier. This is to set it back to a low level of drag. Okay, this is where, see, I told you I'm not good at this. I have to remind myself of what I was even doing. So, if the rear wheel's rigid body angular velocity is greater than wheel speed, remember I said earlier the wheel speed is what the transmission is controlling. It's how fast the wheel can spin. So, if the rear wheel is going faster than my wheel speed number, yeah, that's weird. This is why I'm confused. I have it as a greater than statement because the negative version of add torque gets the wheel going the way I need it to. So it kind of creates this weird, like, why am I doing this greater when this is what I don't want to be greater? But because it's negative, it's less than. So if the wheel velocity is greater than the wheel speed, meaning it's not going full power, I'm just going to say less than, even though it's a negative. But if the wheel is going slower than the maximum speed, then I can add the torque. And so I have this add torque statement. I get a lerp. It starts out right off the bat with a value of 5,000, and then it works its way towards the horsepower times G, which G is the float that we're passing in here. So that's when you're using the joystick, or in the other one where I just set it to 1. So it's times 1. That means it's that number, that full number. And then 10 times the torque. I put in this 10 purely so I didn't have, in the inspector, I didn't have to write a number that's 10 times as big. That's really the only reason for it. And then times time dot fixed delta time. So that is going, your torque right now is 5,000, and then it's going up to the horsepower, which, let me scroll up here because I'm actually taking that horsepower. Again, this was so I didn't have to type in giant numbers in the inspector. The horsepower is equal to the inspector's horsepower times 1,000 times power factor. So the power factor by default is set to 1, and when I want a more powerful vehicle, I can do 1.1, 1.2, whatever. Just to make, for an upgrade, bike can be faster than, at all levels, than it currently is. Let me go back down there. And then, so if the wheel is not going maximum speed, it lets the torque be added. If it's greater than the wheel speed, then it sets the rigid body's angular velocity to be that wheel speed. So in other words, it's saying as long as you're going less than your maximum speed, the power is being added. If you're going more than the maximum speed, it's lowering it to that maximum speed and no longer adding torque to it. And by that, I can control the wheel speed. So as I upgrade the tranny, that wheel speed number gets higher, which means I can go faster. And by upgrading the engine, I'm allowing it to get to that speed faster. And this number, the torque, that number being higher makes it go from this number to this number, from that 5,000, from the 5,000 to the full horsepower number. This being a higher number makes it go to that number quicker. This was something that I struggled with a lot on Moto McSteed. I could make a bike really fast, but it became super hard to control, and the front end was always flipping up and taking off. My brother, who's my sole tester on this game right now besides me, feels like the game, it doesn't get up fast enough now, but if he upgrades, he'll get there. Now I will talk about the brakes. And the brakes work similar. This is where it's getting called in the function. This is brakes with button. Same thing, I have the joystick version of it as well. The brakes are a little bit more complex. First off, when you call the brakes, it's taking the chassis, the brake dive number, and rotating the chassis towards the front wheel by that brake dive number times B, which is this float that I'm passing in. And then it's also taking the rear wheel and saying your angular velocity is going to go from this RWV, which is somewhere up in update. Oh yeah, here it is. So RWV is just checking the angular velocity of both the front and rear wheels. So it's saying whatever speed you're going now, you're going to work towards 0, and you're going to do it at time.fixed delta time multiplied by the braking power. So a higher braking power means you're going to get towards that new number faster. So if you don't know what a lerp is, I don't know what it stands for. I always imagine it means linear or something. But you're working from this number before the first comma to the second number, and this decides how long it's going to take to get there. All right, that was the first half of the braking power, which my original version in Moto McSteed was like all this stuff that never did anything to get it to go to 0. And you could see right here that I tried setting the angular drag to be like 5 million. And even that didn't work. If the bike was still on a hill, I could set that angular drag just, I don't know, if there's probably some limit that they put on it. But I could put it at the maximum and it would still roll. But what I did was I took that angular velocity and I would check it. And if the angular velocity got below that lockup number that I showed you at the top, then I would... Oh, and then also, because it's going in forward and reverse, because if you're rolling forward on a hill, you'd have one number, and if you're rolling backwards, you'd have the negative number. So it checks both of those. So if it's within this range of, I think the number was set to 100 at the top. So if it's between negative 100 and positive 100, then you can lock up. And I did that with the rigid body 2D constraints and just switched on freeze rotation. And then as soon as you let off the brakes, that will turn off. And this number, all of these things took tons of adjustment, just playing around until it worked. And when this lockup number is high, you can lock up the brakes instantly and just, like, the front wheel will just suddenly be frozen. And if you've ever endoed on a bike or something like that, it's that. You get thrown forward and crash and explode. And then, so after all this, the else is just to release all of that. It just changes all the angular drag and all that stuff to be nothing. Actually, this right here is from Moto McSteed. I had a setting to make a four-wheel drive. Technically, it's a two-wheel drive, but it would check if this is if it was a four-wheel drive. It would also add the brakes on the four-wheel drive would be reverse. So that's pretty much it for the wheel power script. So last piece of the puzzle is the chassis control. Now the original version of Moto McSteed had the chassis control was purely done through torque. And so I have this number, the lean power, and that's the number in the torque that it would add, either forward or backwards, depending upon which button you're hitting. And it was purely through that. But one of the things that I wanted to do in this version of the game is have it be somewhat more based in reality by doing the weight of the rider be the reason that it was leaning forward or back. Because it's not exactly the same force. It does create a torque-like force on it. Like if you get back over the back of the bike, it is adding some rotational power to the bike. But that's not all there is to it. I had it working perfectly in the editor, but when I went to iPhone, it didn't work. What I found was with the iPhone, I could not adjust the weight of a rigid body during runtime. It most likely something that I was doing that made that not work, but I couldn't get it to work, so I switched. And what I did was, so I have this, which is connected by a distance joint, it looks like. I experimented with a lot of stuff. It's set, it's a weight that represents the weight of the rider, and it's set to 20. It was just purely an arbitrary number that I put in, and it worked, so why keep going? But then for this version, this is different than Moto McSteed, is I added further controls that actually I have. It's not going to show. These, I have a front one and a rear one. Those are just two separate things that I am setting their mass via the script. But anyway, what I'm doing is I'm increasing the weight of the front object when I'm leaning forward. And that actually surprises me that I went back to that because I thought it didn't work. But there's a lot of things like that. A lot of times I have scripts that are not working and then suddenly they work and I never understand why. So there's a front position and a back position, and all I'm doing is, in addition to the small amount of torquing force I'm doing, I'm increasing the weight of the rear object or the front object. And I think what I found was just doing the weight didn't quite give me the control, especially when in the air. Because if you are in a jump, let me see if I can get it to jump like I'm talking about. If I jump and I'm up in and I'm pointed straight up in the air, adding weight to the front doesn't do anything because the bike has already passed the tipping point. But I've seen riders when they will throw their weight forward, and that causes the bike to fall, in addition to using the brakes and other tricks they do. So I ended up adding the torque force back into it, but far less than I used to. And after just experimenting with the numbers of both the weights, I think the let me go to the script really quick. This is my chassis control script. Again, this is a good example of something that probably someone could do in a much cleaner way, but this way is simple. It's caused me to have to rewrite stuff constantly as I tweaked it, but whatever. So what this does is it sees if I'm leaning back, and then it adds torque to the rigid body based on lean power. And then it takes, the rider mass starts out up here as 20 is the basic. And then it takes that mass and sets it to 0. Makes sure that the front lean position is at 0, and then sets the rear one to 50. And then else if I'm leaning forward, I had that backwards, it's the back one, it zeroes out the rider, zeroes out the rear, and makes the front one 50. And then the last else is just to set it back to the default. I mean, it really is that simple. And then on the one with the joysticks, I'm just taking those numbers and multiplying them by this float that's equal to the amount of input. And the last thing I have is a hop control. It just simulates pulling up, like on a bike doing a bunny hop, or just lifting up. Like if you need to get a little bit of extra distance on a jump, you're lifting up on the bike, using the suspension to help spring you up a little bit higher. So to simulate that, I'm just adding force to the chassis in a vertical direction. And one of the things that I've actually found with this that I can do is in motocross, it's a fairly recent development to me because I've been watching motocross since I was a kid. The scrubbing over the top of the jump. And they do that by laying the bike over and keeping the suspension from springing them up high. That way they can hit a jump at a higher speed without launching so far in the air, because being in the air, you're not getting power to the ground, which means you're not increasing your speed. And one of the things I've found with this spring force is if I hit it at the right time before the top of the jump, it sort of takes that last little kick that the jump would give you out, and I can sort of scrub the jump, which is, and really it's impossible in a 2D game to get something that's accurate to it. And I had actually tried adding a push down force to the game, but it never worked the way I wanted it to. So I think that's kind of it. Alright, I'm going to play through the level really quick, and the sound on the engine's not working for some reason, probably from me dicking around with the script, but so I actually used that hop force, the pull up, to be able to make some of these jumps. One of the things I really wanted to do with this game is that you have to ride the bike. It's not a game where you can just sit there with one finger and press the gas and make it through. It's a game that requires you to actually control the bike at all times. And that's the thing that I love about it. And the fact that, you can actually get a wheelie going with power. And I've been playing around with the joystick controls, and even though I like the button versions better, I can sometimes ride a wheelie with the joystick controls. Like like you know, like I would on a real motorcycle. I'm controlling like the balance point, controlling the throttle, controlling all that stuff. And so that's it. If anyone wants to write comments or questions and wants me to explain any particular part in detail, I will do my best. As I said, I mostly just hammer away at this thing until something works, and then I stop working on it until some other thing that I'm trying to do causes me to go, oh, that's the other way that I solved that doesn't work. And occasionally I'll go back and go, oh, I know how I should have done that, and I'll go back and fix things. But for the most part, I'm just hammering away at this. I don't really have a coding background. I taught myself MaxScript and 3D Studio for some simple tools that I needed to write because, you know, just things that I was just tired of doing over and over. And as I said before, I really wanted a motocross game on iOS that worked the way my brain wanted it to work, and nothing I found out there worked like that. And there's something about side-scroller motocross games that I loved, that I just wanted one, and I wanted it to work in a very particular way, so that's what I made. And I'm trying to get this game out in a month or two. I have a lot of artwork to do and tracks to make, and some games, most of the gameplay stuff I have fairly solid. I'm working out a system similar to Clash Royale where you get treasure chests to open. In this game, you're getting toolboxes. So you have a rusty toolbox, a painted toolbox, and a polished toolbox. And I may add other ones later. But I've got a decent version of that working where you can add the toolbox to slots similar to the way Clash Royale works. And it takes time to open them. I have most of that working, some little things to figure out. But as soon as I get the mechanics down where I'm really happy with them, I can start generating a lot more of the artwork and all that stuff that I need. And then I want the game to have about 100 tracks. And the original game had 54 tracks. The new one I want to do 100 with 4 different types of lands. I'm going to have unlocks for a low gravity mode and other things too. Also, I'm going to do like a rock crawler mode that I kind of created on accident, a way to do it that I think is really fun. It's a really powerful version of the bike that's very slow. And so you can do sort of this trials type riding, but very different than any trials game that's out there. All right, that's it. This is Chris, McSteed TV. Look forward to this game. Let me know if you want more of this. I will record videos of how I'm doing things, like the toolbox unlocking, all that kind of stuff. I'll make everything that I can if people are interested. And also check out the other stuff on my channel. I have 40-something videos that are short films, both animated and live action, that are pretty fun. And subscribe if you want to know more. Thank you.